So today we are going to look at translations on the coordinate plane. So if you can get your composition notebooks out, we're going to take some notes on how ordered pairs can tell us which direction and how far the translation or slide will go. So today is the 17th. And this is translations on the coordinate plane. So we had said that yesterday that we can also describe vectors as ordered pairs. So what that means is that they will have an X and a Y. And they have components. Their components are the X and the Y. So the X is going to tell us the horizontal change. So is it going to go right? Is it going to go left? And how we know that? So the horizontal change is left or right. So just like on our coordinate plane, I know that the X's are negatives over here. And they're negative over here. So to the left, we would have a negative number. The right, our X's are always positive. So if our X is positive, it's going to tell us to go to the right. Oops. So what I'm just drawing over here is just the coordinate plane and what our X's and Y's are. So if our number is a positive, then I know it's going to tell me to go to the right. For the Y is our vertical change. So how far does it go up or down? So we say that's a vertical change. So our Y's, when we are positive, we go up. Our Y's, when we go down, are always negative. So up is positive, or down is negative. So we can describe vectors as how far a point moves. And if we're talking about the coordinate plane, we're just going to say units. So an example, we're going to describe the vector (8, -4). So the vector here, since it is, the X is a positive number, that tells me that I'm going to go right 8 units. Because my Y is negative, it's going to tell me to go down 4 units. So each point, I'm going to move right 8, down 4 units. So if we open up our packets back to page 9, there's an example of moving a triangle on the coordinate plane using a vector that is drawn for us. So if we look at, if you guys could open up your packets to page 9. We looked at vector components or we looked at translating without vector components. Now we're going to look at them and be able to draw them using vector components. So our vector components means the change in the x and the change in the y. So as I said, we can also describe vectors as ordered pairs. I can use ordered pairs not on the vector or on the coordinate plane as well. So if this is 7 centimeters to the right, so how the arrow, 7, that's a +7. And this is moving up 4, so that's a +4. So please do not confuse this with slope. Slope is different than this, okay? So we always describe the first as how far the x moved. So, or the horizontal distance first. So, whatever my original x is, I can add 7. Here, whatever my original y is, I can add 4. So if this point is 3, 4, my new point is 3 + 7, which is 10, and 4 + 4 is 8. That would be my new coordinates for my image. We also have this one over here where it's going to the left 8. So this would be -8 and 3. So what I can do is if I start with points 1, 2, now I'm going to add -8 to this. So -8 plus 1 is -7. And 2, this is up, so it's a positive, so 2 plus 3 is 5. So this would be an example of how I get my points. So 1 plus -8 and 2 plus 3. That's how I got -7, 5. So I can do that with each one of my vectors here, or with my vector down here on the coordinate plane. Something that's pretty nice about this is drawn for us. So I can easily determine what the points are. So here I would go 1, 2, 3, 4, 5 to the right, since that's a +5, and 1, 2, so that's a +2. So I know that every point, I know I have to move right 5 and up 2. So I'm going to start here at this point here. So 1, 2, 3, 4, 5, up 2. So that is this point. I take this point, 1, 2, 3, 4, 5, and up 2. Make that point. This point, 1, 2, 3, 4, 5, up 2. So now, all you need to do is connect your points with a straight edge. And we have our translation on the coordinate plane. The next 2 pages, you're going to be asked to do that, not just moving, but actually thinking about what the coordinates would be if you know a vector. So don't forget, we're always going to add our x and y components to our vector to our original point. So here, to get 10, I took 3 plus 7, which is here. And then to get 8, I added 4 plus 4. So that's how I got my new points. All right.